Thank you, Rick, and thank you, everyone. Good morning. So, as Rick mentioned, we're here with Analog Devices, and I'm joined by my colleagues Grania and Mary over here in the front as well. So, if a few folks can answer questions for you if you have any later. And today, I think I've got roughly about an hour and a half, maybe a little less at this point, and there's a ton of material we kind of cover here. I think the intent of this was to kind of make it interactive. Right, so as Rick, feel free to interrupt with questions as things come up. I'm going to spend some time going through kind of a quick overview of who we are. I've got a bunch of slides as well that can talk to various kind of things we're doing in IoT. But part of what I was hoping we could get to today as well is that there's some new tools that we're leveraging around extending some of the work we're doing into cloud as well that I want to kind of show you and give you a chance to play with and maybe get some feedback on as well. So I'll talk about that a little later. I got a question earlier if a computer was required for this. It's not, right? I think that there's certainly the content here, and I think maybe you can grab like a snapshot of the QR code or even grab a photo of the pages that are set out on the desk in front of you before you leave. But you'll be able to grab some of this material later if you want to, take a look at it and follow up, right, as well. So. Maybe to get started, I want to just spend a few minutes sort of introducing Analog Devices, who we are, and then talk about some of the things we're doing in IoT. So maybe to begin, ADI is a company that has been, we're a Massachusetts-based company, worldwide presence. We have about 15,000 employees around the world, and we've been in existence now for about 52 years. Our focus is very much on enabling our customers to make products that disrupt, that are innovative, and really kind of bridge the world between the analog and digital worlds. Excuse me. So I think we really kind of focus on helping our customers solve the really hard problems. Right, so when you're dealing with kind of the real world, it is messy, right? Analog signals by nature tend to be noisy, they're interfered with, and part of the technology and where we kind of really excel is in kind of making sense of all of that, right? And as I said, bridging that gap. We were founded in 1965, and we just have a sort of a rich history in kind of working in the analog digital measurement, sensing, and now communication spaces, which kind of puts us in a really good position in terms of to help customers in the IoT space, which very much is kind of trying to understand what's going on in the real world and make sense of that. I think there's various kind of levels that we operate. Our core technology, sort of in the bottom here, is kind of focused on these areas of sense, measure, power, connections, and interpreting. There's a variety of different products we bring to market in the sensing space, MEMS and optical. Our bread and butter and where our history and experience is in the measurement pieces, where we build complicated analog and digital systems and that are very high performance and allow you to make the best measurements possible in the world. We have a large capability in power for really enabling optimization of power performance on systems. We have a full kind of range of RF connectivity solutions, all the way from very low frequency all the way to the highest RF frequencies possible. We do a lot of work with our digital signal processors and microcontrollers, really pushing kind of intelligence to the edge. And then as we kind of move up the stack, there's various platforms in from processing and algorithms and analytics that we've are involved with, and certainly smaller companies and that we've acquired over the last few years have really been targeted at helping us move up the stack from silicon all the way to software and into cloud. There are a lot of different areas we focus in, and we have a very broad portfolio of products as well. The main areas, I think, touch these ones here: communications, aerospace and defense, automotive, healthcare, consumer energy, IoT, of course, instrumentation, industrial sensing, and then automation. Probably around 40% of our business is focused on the industrial space. And the main areas I would say of focus for IoT for us today are in the healthcare, industrial, consumer and energy to some extent, and then sort of growing into automotive as well. We have a pretty big presence as an automotive supplier. Sort of kind of what we do, we manufacture a broad portfolio of solutions, that leverage our mixed signal, digital, as well as sensing and measurement capabilities. We basically deliver solutions that, can really measure and interpret the world around us. Portfolio of over 45,000 products used by over 125,000 customers in the world today. We're roughly today now, after our closing the acquisition with Linear Technologies a few months ago, we're close to about a $5 billion company, and we have about, as I mentioned earlier, about 15,000 employees around the world. So I think when it comes to Internet of Things and IoT, as I mentioned earlier, there are certainly areas that we're focused in. But kind of what we bring, and I think what we bring to the picture, which is valuable for our customers, is capabilities around precise measurement, at node processing, and we'll dive into that and talk a little bit about that shortly. And then, really in some respects, superior technology across the whole signal chain, right? Some of the areas we've got active today in smart city, smart building, infrastructure, smart industrial plant manufacturing, smart health, agriculture, smart machine, and smart energy. And if you look, I think as Rick said in his introduction comments, we're in booth 520 down on the floor, and you'll see kind of examples of all of this kind of work if you have some time to stop by during IoT World here this week. I think because of our history and our experience and our technology, we really can solve problems that couldn't be solved before in many respects through our advanced sensing and precision measurement. And we offer kind of secured and connectable scaling or sort of wireless sensor and networking capabilities. And a lot of work we do, which goes back many years on our algorithms inside now, is kind of really branching into sort of more advanced analytics and capabilities that sort of to algorithms that we run on the cloud as well as on our edge devices as well. Okay, so some of the notable partnerships we have in this space today, we're working with LifeQ on their leveraging their computational biology platform. Snap Sensor is a small company that we started partnering with and then acquired last year. They have some interesting technology around sort of CMOS imaging and processing you can do for occupancy sensing. I'm going to show an example of that a little later. And then consumer physics, where we're leveraging the SIO material sensing capability, and we have a demonstration of that downstairs. So other notable kind of additions to the Analog family over the last couple of years are Cypress Electronics. These are a leader in security, right, and government and nation-state level security. We're leveraging their technology in our IoT systems. And then with Linear Technology joining us, we add Dust Networks to the portfolio as well. And again, Dust are many ways a leader in wireless sensor networking capabilities, and their Smart Mesh IP, I think, is certainly one of the more robust and reliable sensor networking systems that's out there. So I think one of the themes that's kind of driven our IoT kind of journey, if you will, certainly over the last couple of years, is that this notion that this was fairly visible here last year, that the prevailing wisdom in terms of IoT systems was really to try and figure out how to get as much data to the cloud as possible, and then kind of assume that algorithms, analytics would take care of making sense of it, right? I think the reality, I think, as we found, based on our history, is that the world is much more complicated than that, right? And the real issues of doing deployments, maintaining proper connectivity, and even dealing with the data volumes, right, and the cost effectiveness of shipping large amounts of data to the cloud, do present quite a lot of challenges. Another area that we run into as well is that in a lot of cases, when you're deploying sensors, often you want them to be completely autonomous, which means no power or no power sources, right? Not always the case, but in a lot of cases you need them to be energy independent. Now, whether that's battery powered or running off some kind of harvest energy source, that is definitely a desirable attribute. And so when you run into direct conflict then if you're trying to ship a large amount of data, raw data from your edge sensors to the cloud over in power constrained systems, right? And so therefore the more work you can do on your data right at the edge, the better off you're going to be. And that really comes down to the fact that, given the where sort of deep submicron chip technologies have taken us today, it's a lot more efficient to do processing using local processors and just, like ARM cores or some of our DSPs. It's a lot more power efficient to do that locally than it is to actually light up a transmitter and actually send data over a wireless network or even a wired network as well. And so, for us, I think the focus from us has been on, really where we have lived for many years in the bottom here, where we do a lot of the interpretation as well as sort of the measurement on the edge devices themselves, and then really just ship the data you need to the cloud. Right, and so for us, that kind of puts us very much as I would say, a leader in sort of the notion of edge analytics and edge signal processing when it comes to deploying IoT devices. And again, we've got lots of examples of that downstairs, and I'm going to kind of briefly, shortly, just kind of run through some here. So I will just take a point at this point is that, like I said, the slides are available, right? So on that Dropbox folder, this presentation is there. I probably won't go line item through every one of the slides I have here, but I include them kind of as reference for folks to be able to come back to later. So I think, I'm covering a little bit of this again already. I mean, the areas that we focus on, the various skills that we bring in terms of system integration, sensors, connectivity, low power, and ultra low power is a real big focus for us on this idea of combining, for example, sensors, connectivity, low power performance, and security into really kind of robust and secure wireless or energy independent edge devices. So that's a big focus on kind of a lot of our vertical engagements in some of these vertical markets here. So I think, looking at the portfolio of things that we have, we have a large portfolio of sensors. Signal conditioning and signal processing, both in the analog and digital domain, is a huge part of what we excel at. We have, with the acquisition of Linear Technologies, we have a very large and industry-leading power portfolio of devices. We have we use ARM for a lot of our low-power microcontrollers, but we also have a set of digital signal processors, our Shark and our Blackfin lines that, also, certainly in the case of Blackfin, it was designed for low power, kind of pretty intensive processing applications, especially video, and I'll show a couple of examples of that here in a moment. And then there's a range of connectivity options that we have as well, all the way from infrastructure, cellular type infrastructure, radar and high performance communication links, down to, very low power, and moderate bandwidth links like we enable with our Dust Network Smart Mesh IP. There's a bunch of work that we've done on building out our sensor capabilities, right? We refer to this as our more than Moore strategy, so moving beyond Moore's law in terms of, adding value with silicon. And what, the types of sensors that we've kind of worked on, and we are really ones where we can differentiate by essentially integrating sensor capability into silicon. Right, so I think in some cases, there's some groundbreaking work on this space. Like, for example, in our MEMS or electromechanical or microelectromechanical sensors, these are primarily targeted at inertial sensing. So the sensors we integrate, kind of replace sensors that were box-type structures. Right, and what we found is that, although some of the performance, on our gyroscopes would not be as good as, say, a laser ring gyro, but what we found with the appropriate level of signal processing, you can actually get performance that kind of, gets up there. So you're talking about tens of dollars for a device versus thousands or even, tens of thousands of dollars for a device. And with very, very high performance and low power. So sensors like that are kind of game changers. There's work we're doing in all these other areas as well, where our focus is on sensing technology that we can bring into silicon, so we can kind of reduce the power as well as the size footprint of the devices that we build and bring to market. Security is another big, area around IoT specifically, but just generally when you start connecting devices, up to various networks and then ultimately to the web. There are various levels in this stack, all the way on the bottom, from your basic data, and edge sources to, the fog cloud, enabled through gateways, and then onto the actual, distributed network cloud itself. One of the key acquisitions that we made last year, as I mentioned earlier, was we bought Cypress Electronics, and, a key part of the IP that came with that and we've been developing is the Cymetrics intrinsic identity IP. And basically the premise of this is that in a lot of cases today, security for devices is assigned. Right, so you will basically, at some point in the manufacturing flow, you will enter a set of keys, right, that identify the device, right, and as a consequence of that, the keys are known at some point in the supply chain, right, and therefore can be compromised, right. The premise of our Cymetrics technology is that we actually extract the identity from silicon, right, and then therefore the keys never have ever left the device, right, and basically this interoperates with sort of kind of standard sort of public-private key type systems, and the private key is what gets generated by our device, and then we can produce a public key from that. The thing about this is that it allows us to kind of essentially now not only establish a root of trust, but also manage a chain of trust all the way from the edge device into the cloud itself. And we have development activity going on in that space right now. So I'm going to just segue a little bit into some applications, and I've a bunch of material here. I'll try and skip through as some of it, but I think that smart machine, given the, is there a question or? Sorry. So smart machines, given our focus on in industrial, is kind of a big thing for our customers. And some numbers, from kind of late last year, a lot of manufacturers have not implemented any kind of predictive maintenance program, right? And in a lot of cases today, maintenance programs are still manual, right? Which is not necessarily the most cost efficient. And there are other areas in, kind of like energy and heavy industry where predictive maintenance, is already, kind of a big part of those industries. I mean, you look at some of the things like GE, what GE and Rolls-Royce are doing with engines, right? They're, some of the latest GE engines, I think, have got like hundreds of sensors built into them and generate terabytes of data, per flight, right? Another interesting point that 75% of organizations that have deployed predictive maintenance systems, have reported a very positive ROI. And there's one example I think we've done internally in one of our wafer fabs that I'll tell you a little bit about in a moment. And 60% of respondents, for a survey have basically reported improved or improvements in the breakdown frequency or reductions in the number of times equipment breaks down. And only 40% of manufacturers are comfortable with remote monitoring over the internet, right? So we see in industrial applications that IoT, Internet of Things, is not always applicable because for reliability, security, and even data privacy reasons, some big manufacturers don't necessarily want data leaving their premises and on-premises networks. And certainly, the experience with our various manufacturing sites is sometimes various parts of the manufacturing operations are firewalled from each other. On private networks, just to, again, it's more about maintaining, the integrity of the data on the network and making sure that you can't have downtime on those networks. So the source of this was from Lux Research and this predictive maintenance, survey that they published back last year. And some of the things that I think we've learned is that maintenance, for example, is just really the tip of the iceberg here, right? There's a lot of other things that come from being able to monitor and understand what your systems are doing. It offers the opportunity to make savings in energy costs. Capital costs can be reduced if you're getting better uptime in your systems. The environmental costs, you're not generate as much waste from systems if you're more efficient. And for example, there's some studies that say, from the Department of Energy, that predictive maintenance can actually be shown to reduce energy consumption by up to 14%. Right, so these are pretty significant things once you start down a preventative maintenance program. Some of the other benefits. One example of this is we have one of our legacy ADI wafer fabs is in Limerick in Ireland. And then we have a second fab in Wilmington, Massachusetts. And these are pretty representative of what would be considered brownfield sites. So they're existing sites. They've been, as opposed to greenfield, where you're building in instrumentation into new equipment. We've had a fab on our site. Our site was set up in Limerick in 1978, and I don't remember when the fab actually opened there. But it's a good, 30 years at this point. pretty much from as long as I've been with the company, there's been a wafer fab in Limerick. And so the consequence is that there's a lot of equipment in the fab that is very new, but also pretty old, right? And it's well past depreciated, but still works perfectly fine, and allows us to continue to manufacture devices that have been in production for sometimes tens of years. But it isn't. But so one of the biggest challenges we have is not often in yield, right? Our yield performance and how we do out of these fabs are really, really good, but the challenge often is just you want to avoid unforeseen breakages and equipment breakdowns, right? And so, some of the work that we've been doing, it has been in, let me skip over this, in sort of instrumenting some of the non-instrumented devices and then integrating that into our own kind of factory management system. And I think, we've had this project underway for close to 2 years now, and there's already evidence where it is returning a positive ROI for us in terms of reduced downtime and consequently improved yield on the output from the fab. Some areas of, where you might sort of see, if you look at sort of the sensor performance axis on the bottom versus the, processing stack on the left-hand side here, I think that there is this sort of trade-off, in terms of the capabilities that it kind of enables, right? So on the cloud processing or the processing stack, certainly, condition monitoring, measurements, diagnostics, you can kind of do close to the edge and generally get really, really good feedback very quickly as to whether a system is going to be in an error state or not. But if you want to look at longer-term trends and move much more into a predictive state, then you really are relying on the cloud processing capabilities that enable things like machine learning and AI, right? As the sensor performance goes up, moving towards the right here, the quality of your diagnosis becomes a lot better because you have a much cleaner signal now in which to work with, and you can look for more artifacts, in the signal itself. And so, some of the area we're focusing on is leveraging our sensor performance and then coupling that with capabilities that are both edge processing based and cloud based. And just an example here, I think, of what you might run into, the type of problems we're analyzing in terms of motor-based systems, whether you've got a pump or a fan. There's usually a gearbox and some drive motor. And the type of errors are kind of listed here where you can have misalignments, bearing errors, even cases where the shafts get bent. And various lags due to inertia in that on the loads and imbalances and so on that can cause problems. And these tend to manifest themselves as kind of various kind of signatures in terms of on the bottom here where we're looking at different artifacts that show up depending on the type of damage. One of the sensors that we have released recently is our new ADXL1002. I don't have too many product mentions in this, but I think this is one of these products that, for us, I think is really key because for many years the industrial vibration sensing market has been dominated by piezoelectric sensors because of the bandwidth and the noise performance capabilities of them. And we believe this part is kind of the first MEMS-based part, which actually has the performance level on par with piezoelectrics in for vibration sensing applications. A couple of key advantages, though, of MEMS is one, it'll allow you to measure all the way to DC, right, which is piezoelectric sensors definitely have trouble with. And that's key because sometimes artifacts can be very low frequency rumbles, right, that are not necessarily easy to pick up otherwise. And then the other thing is MEMS sensors are very robust, right? So some of the sensors I've worked on in the past, we've shock tested these things to 5,000 Gs, and that's kind of what we specify in our data sheets that they're capable of dealing with. They don't need to be recalibrated, right, once you've calibrated them in situ, whereas piezoelectrics tend to be a bit more finicky, a bit more fragile. So, a key part from us here. I won't spend too much on this one, but there's a range of different sort of embedded microcontrollers and DSPs that we have, that are very suitable for edge processing in these type of environments. From ARM-based and also some of our own ARM and Shark-based processors as well. Now, of course, power or sort of just measuring vibration is not always enough, right? And sometimes the best ways of getting at a problem, right, and understanding what's going on with a piece of equipment in an industrial setting is to have multiple modes of sensing, right? So, and this idea of sensor fusion and being able to correlate and align data from different sensors. And so energy metering is a big piece for us, right? There's different tools that we have available for doing diagnosis, power quality measurements, and various things for doing diagnostics. One thing I don't have a slide on here, but maybe I recommend you check at our booth downstairs, is that we also have a thermographic monitoring system that was built as one of our incubation kind of initiatives within the company. And this basically is a remote camera-based system that can actually monitor fuse boxes, right? So I mentioned power. One of the big issues in plants is that you have these really, really large thermal fuses that are used to often, rated for hundreds, maybe thousands of amps in some cases, that are very, very dangerous to be around when they're live. And so the standard way of testing those today, or measuring the quality of making sure you don't have arcing or bridging problems, is to send a guy in there with a measurement and actually measure the fuse resistance and other parameters, which means the whole system has to be taken down, and de-energized. This Sentinel system, as we're calling it, actually allows you to do it remotely, right? And then we use some cloud-based machine learning to actually, keep track of images from the sensor as they change over time, and then to identify when a potential problem is going to happen. Okay, so it's not listed here, but it's one of the newer solutions we have as well. So, one of the reasons that sort of electrical analysis is really important, or electrical signature analysis is really important, is that a vibration analysis is only going to get you, be able to identify some of the problems, right? So when you actually get into the motor itself, there are various issues related to the rotor and the stator of a motor that can actually, be identified much more readily with looking at the electrical signature of the device rather than the actual vibration signature. The electrical response can also give other indications. If you're having bearing problems, you're putting additional stress on the motor, and so the energy signatures will change over time, and this is something that can yield very useful insights as well. So, I am an engineer, so there's always going to be waveform slides and frequency analysis slides in some of the stuff we do. But this is an example of an electrical signature analysis that's actually showing some, harmonics here that are showing up that indicate kind of broken bars or broken rotor bars in a motor itself. So again, these things can, easily be analyzed over time. You can look at the harmonic signature and then look for changes in that over the operation as an indicator of a potential fault. All of this is enabled by our measuring technologies that we have available, and then algorithms that we actually run on the edge. And we're actually exploring some options right now about how we make them available in the cloud as well. Okay. Okay. So I'm going to sort of start to accelerate here a little bit. Material sensing, I think I mentioned earlier. So we've partnered with Consumer Physics to bring their SIO solution to market. And, there's a broad, this leverages a combination of edge processing and cloud processing, to be able to identify the contents of specific materials. And I think some of the areas I think that this is really important is that when you look at sort of, consumer safety, right? So in lots of parts of the world, maybe to a lesser extent here in North America and Europe, fake drugs, cosmetics, poison materials that are often show up in food, right? Are real safety issues, right? And there's some examples here of some of the problems that come up because of this. There was an incident, I believe, in China a few years ago where, babies were affected by and hospitalized by contaminated baby formula. Fake cosmetics, as I mentioned, fake drugs is a huge issue. And so technologies like material sensing potentially put power in the hands of consumers to be able to, identify foreign substances or even fake or problematic either food, drugs, or other materials that they interact with in their daily lives. So we have a demo of our SIOS solution downstairs as well. Vital signs monitoring, I think, is the last use case I'll just kind of talk about here for a moment. Sorry, I've got one more. And then we'll kind of move on to some of the workshop-related things. So in the area of wellness, I think there's a lot of systems out there today, Fitbit and so on, for example, is one example where, people or consumers basically can have gain insights into how fit they are in their daily activities and so on. Now we've certainly got some customers in that space that are using, especially some of our low power technologies in those applications. But one of the areas of focus for us is, through our capabilities around better sensing and measurement, is really kind of moving some of this wearable technology into the clinical domain. Right, and why this becomes very important is that for any of us who interact with our doctors or medical specialists, right, we'll go see a doctor. Maybe it'll also be some tests run, and any diagnosis or or any prescriptive plan will be based on that, right? Those it's almost like a subsampling, if you will, of information. So one of the things that our technology enables is the ability to build these clinical grade bracelets and wearable devices that doctors can prescribe that patients wear them for an extended period of time and be able to gather clinical grade data on whether it's heart rate, other aspects of the body performance. And so there's a ton of work we've done in this space where not only are we doing enabling through our really world-class sensing capabilities, things like optical sensors and inertial sensors for measuring heart rate and so on. But some of the processing we're doing, for example, we've got some algorithms we've built and deployed that will basically measure heart rate right off an optical sensor, but then use a MEMS accelerometer to reject some of the motion artifacts that come from the fact that you're moving around and can actually kind of introduce errors in the measurement. And we're leveraging cloud capabilities, not only to kind of interact with our own healthcare partners but also to kind of enable our creation of many more algorithms, right? So through gathering kind of data, and then being able to leverage that information and data to actually create better algorithms and enable our customers to do the same thing as well. So we do have examples of some of these wearable devices down in the booth. Sorry, I'm doing a lot of plug for our booth here today, but it kind of is a carry on. Thanks, Rania. But it definitely, kind of showcases the wealth of technologies that we do bring to bear, and also the application spaces that we do bring to bear in this space. The last one is around sort of specific use case I want to talk about is in sort of the industrial and occupancy sensing, right? And it's not industrial, excuse me. So in the area of people sensing, building, monitoring, and also smart city applications. So a lot of different images here, but some of the technology we have and all of the images we're showing here are actually kind of the analytics are done on edge devices. I referenced Snap Sensor earlier, on the CMOS imager and algorithm side, and then also our Blackfin DSP, which is a very low power device for doing edge processing. So what I'm going to show here is here's some examples of things that have been detected either in buildings or in the street. And a specific example here with Snap Sensor, and this is a partnership that we've done with GE, right? You'll see the video playing here on the right-hand side. I appreciate there's a little bit of a shine on the screen, so it might be tricky. But from the sensor itself, we've actually identified these open parking spaces. So this is actually a deployment now to go test a smart parking application. And as the car kind of pulled in here, the space lit up, right? And it was identified as being occupied, right? Now, obviously we're showing video here and an example of a video of essentially a video application. But one of the key things about this, going back to some of my earlier comments about power management, right, is that the only information that we send off this device when it's deployed to the cloud, right, is just the metadata associated with the parking spaces, right? So rather than sending a full screen image, which could be, essentially will run megabits or megabits per second, even with some moderate compression, well, all we send is like the number of parking spaces, right? Maybe even some identifier information about each parking space, and then which ones are occupied and not, right? And even we can also keep track of for how long, right, on the edge, right? And then that information then proves or becomes the basis for the cloud-based systems that would be generating dashboards, maybe to traffic enforcement, police, even long-term tracking of parking space usage, so cities can more optimize, their parking, right? And for example, if their spaces are used all the time, it might suggest they need more parking. If they're never used, then suggest maybe they could do something else with this space, right? So we've had a lot of interest in some of this technology in the smart city space. And again, I believe we have a demo of this downstairs as well. Okay, so Well, so just sort of maybe to wrap up a little bit on the, the devices, side, and some of the, sorry, not devices, but technologies that we are bringing to bear. So I had some slides earlier about our sensing capabilities. But one of the things I want to highlight as well here, as I segue into our next section, is that the importance of partners for us, right? So there are a lot of things that Analog Devices does really, really well. And there are some things we don't have a lot of experience with, right? And we're fortunate to be able to work with a range of different partners here, especially in the IoT space, like Amazon Web Services, Dell, PTC ThingWorks, ARM, as I mentioned, they're a supplier of ours, and also work we've done with IBM Bluemix and Microsoft Azure, leveraging their tools to build out our IoT ecosystem, right? So moving, beyond silicon, to the cloud, and with a variety of different systems that are available today for customers in our processor space, development kit space. We have what we call our Circuits from the Lab program, which shows literally hundreds of different ways, methods for doing sensing and measurement, high performance measurement on the edge. We leverage a range of third-party hardware, including I've got some examples here of an Advantech gateway, which works with our DUS networks. We're a partner with Dell using their gateways, and then some other wireless connectivity systems, which I'm actually showing here at the moment, as well as complete edge systems that we've built, including this is an example of one of the watches. Again, I appreciate it's a little hard to see it on the slide here, as well as some of the snap sensor implementations that we've built. Okay. So I think next I'm going to sort of talk a little bit about some of the work we're doing in cloud, right, and to introduce you to that, and hopefully we'll have enough time to give you some chance to play with some of this. And so we're kind of rolling out what we're calling our Analog Devices Connect, cloud platform. I'm a little leery to use the word platform because that has a lot of connotations in this space, and I'd like to spend a few minutes just explaining what I mean by that. Right, so one of the things that we get from our customers is that customers are increasingly looking to us and other vendors as well to help solve more and more of their problems, right? So to deal with a lot of the fundamental engineering, so it allows customers to kind of focus on the specific IP they bring. So a lot of our customers may not be measurement or sensing specialists, but they need those capabilities in order to be able to build a product, say an industrial product they may want to build. And we're seeing increasingly where customers are also looking for help with cloud, right, and how to kind of build cloud systems, right, and even leveraging looking for IP, and different technologies that they can use in the cloud that sort of help them solve their problems. So some of the work we've been doing has been around kind of bringing some of this capability to market. And so what Analog Devices Connect is for us, it's our branded cloud development platform, which is really targeted at enabling our customers to develop IoT solutions using our products, right? And really the goal here is to abstract the complexity of building IoT development. Anyone who's kind of building IoT systems today realizes that no one company can kind of really do it all. We're all leveraging different capabilities, and kind of it's kind of why it makes why opportunities and events like this are so important. To the opportunity to understand not just what maybe your competition is doing, but also kind of what opportunities for partnering there is out there to sort of so companies can kind of help each other out. One of our goals with this is we're really kind of targeting expertise elsewhere or non-cloud developers, right? So a lot of our customers have deep experience doing various measurements and are using our measurement capabilities, and are trying to understand how to leverage cloud and modify and update in many respects their business models. A lot of these folks don't have cloud expertise, right? And maybe you're not in a position where smaller and medium-sized companies can hire an extensive cloud team. So there's opportunities we feel for us to help some of those folks out here. And the sort of the system here we're looking to support is the smarter edge node idea that we've talked about earlier, where a lot of intelligence on the edge, and then the capability to build cloud applications, that leverages that capability. I think it's also important in this context for me to point out what this is not, right? So we're not intending this to be another broad market IoT cloud platform, right? There are a lot of really good options out there today, and some of those capabilities, we're leveraging in various work we're doing with our customers. So we don't really see this as kind of another competitive offering, right? I think, we're really looking, to leverage the best of what's available, right? Sort of, and make it kind of available to, to our customers. And sometimes that's at customers using the tools that we deploy ourselves, and in a lot of cases it's actually working with partner networks, right? So where we would work with, say, companies like Dell to actually bring a joint development to market. We're doing some of that work with PTC ThingWorx as well. So it's not just an either/or. There's a range here. And I think the key thing to point out here is that we're also looking for partners as well. So part of our presence here today is to kind of understand are there ways that we can work together with other companies as well to kind of build better solutions. But I think that we've identified this area with our customers where they're looking for our help, and part of what we're doing here with this deployment is offering that. So I'm going to spend a couple of slides just saying a little bit about what's involved here and what this is. We are leveraging PTC ThingWorx as well as some custom AWS-based services that we've built ourselves for this. And one of the key things about the platform is the object-oriented thing model, which is a little different than if you're building kind of services on AWS, where the operations on your data are in different places, depending. You basically build a pipeline, right? The advantage of sort of something like a centralized thing model, where all your data and operations are in one place, is that it's very developer friendly, right? So it makes it really easy for folks with very little experience to be able to start, building systems, right? Very little cloud development experience. So some examples of some of the services that are available here out of the box, as well as some of the stuff we're doing some work certainly in the analytics and algorithm space. But things like storage, data storage, rules engines, alerts. I mean, you can go through a list of features here, and a lot of cloud platforms have those today, right? But I think that I think we particularly like the fact that everything is kind of in one place here. So from a developer perspective, it actually works really, really well. The UI is pretty friendly as well, and hopefully we'll get an opportunity to test drive that in a little while. For folks that which come from like ourselves, that come from extensive signal processing and algorithm development backgrounds, leveraging tools like LabVIEW and the MathWorks tools like MATLAB and Simulink is kind of a part of our bread and butter, and it enables us to abstract some of our algorithm and analytics development capability as well. Well, the platform here, this has a drag-and-drop user interface for building applications, which will be familiar and certainly friendly, for folks that are not, used to doing, deep web and cloud development. And again, we've had a lot of good feedback on this so far in using this and partnering with PTC to bring this to market. But now hopefully we give you a chance to play with that as well today. So just to say a little bit, I think you should have access. There's some, there's a QR code and also a link to some various materials that I've kind of downloaded here and made available for folks. I think there's a couple of documents that are in this already. The presentation that I have here today is in this, and then there's a couple of exercises that we can kind of spend a little bit of time maybe walking through here now, as well as some code snippets that are used in probably the last one, which I don't expect that we're going to get to here today to look at. There's a couple of hardware examples that we actually have here that I want to highlight, and I've actually got 3 sensors that are moving or sending live data up here today in front of me. One of these development boards is our ADI CUP360, which is available now. It's a low-power ARM Cortex-M3 based device. It uses Arduino, Uno, and PMOD connectors for connecting up a wide variety of sensors. And we actually sell a lot of shields ourselves, but we interoperate with other Arduino-based shields as well. I also wanted to highlight a newer board that will be available later this summer, I think actually in the next month or so, I believe, which harnesses a much lower power MCU that we just released earlier this year. And it is an ultra low power ARM Cortex processor. This one actually has connectivity built in, right? So it actually has an integrated BLE radio on it, and then also an optional, it's included, but Wi-Fi. We've included one of the small form factor espresso designs in this.
How much processing power do LPUs take?
So on the overall scale of things, it's relatively modest, but I believe that this processor here is about a 40 megahertz device. You're not going to be running a full-blown operating system on this, but this board actually supports ARM Mbed, right? And we will be supporting the ARM Mbed development tool. So it's that class of constrained device, right? And I think the performance on the 360 is roughly similar. I think there are differences on the devices in terms of this has a fairly comprehensive and high performance analog front end built into it, right? This one has some more modest ADCs, but it's because it's really focused more on the ultra-low power arena. Yes, sir.
Question, why you pick the other three versus
I think, so we do have actually, the follow-on device for this is an M4-based device, and we have a range of both, right, in our portfolio today. I should say about this, and I didn't say this earlier, that, that we don't consider ourselves to be a mainstream microcontroller house, right? There are other companies like ST, and, that we often partner with to our distributors that actually have that breadth of portfolio. Where our focus is when we add value. So in this case, the addition of, analog sensing capabilities built integrated onto the device ourselves are where we add value. So we would never, I shouldn't say never, but I don't believe we have any cases where we've actually put out a microcontroller that didn't have some and often a range of data acquisition capabilities built in.
Yeah. It's just that the M4's got instructions that the four-man's DSP processing.
Yes, and I think that's one of the reasons that, so we've had to trade off over different generations of products, the power performance, power versus performance and capability, right? So I think that, certainly, as we start to, and certainly as we bring newer technologies to bear, because you also have to kind of rate some of this with the specific processes you're running on, right? Whether it's 90 nanometer, down to, some of the work we're doing in 40 nanometer right now, where you follow the power curve down. Right, and so there's often a trade-off between the power level you want to support versus the performance capability. So I think some of the next generation of devices that we'll be bringing to market will be M4-based, and we already have some M4-based devices today. But you're right. I mean, some of the floating point unit that's on that is pretty capable, pretty powerful. So. The one thing I found, so I spent many years myself actually working with our DSPs, right? And when it comes to moving data around the place and sort of dealing with sort of high performance data pipelines, they're pretty impressive. Just you can sort of one instructions gives you an awful lot of capability. So it's still been a bit of adjustment for me to get used to the ARM devices, which have are a lot smaller, a lot more smaller footprint, less flexibility in terms of how you move data, but really small code footprints, very, very low power. So definitely in the trade-off, in the arena of a trade-off. So to show you sort of specifically what I'm actually running in front of me today. So I've got an accelerometer-based design. This is using one of our very low power, ultra low power accelerometers that can basically kind of go to sleep in the nanoamp range and then kind of wake up for various events. And the power dissipation when this thing is running is kind of in the microamp range. So it's very, very low power, designed to run on with battery systems coupled with one of those other low power devices that could be deployed for anything from 5 to 10 years and just be as I said, energy independent. We also have one of our a very ultra low light light recognition system, right? So which is one of the devices here. So for smart ag, right? I think and measuring light measurement in lighthouses and lighthouses, glass houses. This I think is really key. And then the final one I have demonstrating up here today, and there's a few more down in our booth, is a low power carbon monoxide sensor. So this sensor is not ours. I think it might be a Honeywell device, although I'm not 100% sure about that. So again, an example of where we're partnering, and leveraging other capabilities that we don't have ourselves to bring a full system. So another question.
Basic question.
Yeah.
How are you connecting the sensors to 360? Are you physically connecting?
Yes, they're Arduino shields. So it's a little hard to tell from here, and I kind of broke them out on the picture, but actually, just give me one. What we're actually using for connectivity here is another partner of ours, Inventec. I have a Wi-Fi shield that we're using here. And just to answer that question directly, it's a little hard to make out the stack here, but I've got 3 boards that are just Arduino stacks. The controller's on the bottom, in this case the CO sensor's in the middle, and then we're just leveraging the Wi-Fi shield on top. So. And that's the case. So, we have a range of different sort of connected sensing capabilities that we have available. All the source code is available, and there's a link somewhere in one of these presentation docs that would actually, if you're interested, that gives you actually links to the source code for these projects, so you can actually download them and use them yourselves if you wanted to. And then, we're using the Connect Cloud platform then to actually kind of, do some dashboards on the data. Okay. So let me just jump to that for a moment. Okay, so this is an example of just one of the accelerometers, or actually the CO sensor. It's just a slide from or actually just a screenshot. actually, before I jump to the demo real quick, you know, and actually invite you to kind of play along, if you will. So I think this is the link to the actual site I'm on. I've created a sort of a guest username and password, right? Folks here are kind of welcome to kind of jump on that link. You know, I'll leave it for a moment. It's basically dfae.connect.analog.com/thingworks. We'll get you there. And then the username password are IoT World Guest. And same, it's capitalized ITWNG. So IoT World Guest can get you on there. And so if I just kind of look at the sort of those 3 different exercises kind of that are kind of included in the materials here, right? So one is just to kind of build a simple mashup. We're going to use the accelerometer and basically, you know, just kind of show the data coming off that. That's relatively straightforward to do. And I think what I'm going to do is that, you know, just given that it's now just 5 minutes past the hour, I'll maybe start to walk through this. I mean, folks at any point are just welcome to jump on this. Like I said, I'm going to leave this up for a while, and you will, you know, for the next few days, and you will have my contact information. I'm going to be on the demo floor over the next 2 days, you know, hanging out. So welcome to kind of come grab me on this as well. Yep, sorry.
Is there just any way they could dim that light in front of it?
We had that conversation earlier, and unfortunately not. Yeah, it's an unfortunate placement. Well, here's a question. Can we turn the lights off in the room? This would make it really intimate and cozy, but I don't know if that's an option at all. But yeah. So, so I think the middle exercise here is a little more irrespective or of what you might do in a real application where there are multiple devices kind of deployed around the world, right? So we've done some examples of this. We did an internal exercise, you know, about a year ago where kind of to test the capability of the platform, we had about 50 of our field applications engineers around the world actually build a pilot project, deploy it, and actually get it connected to the into the platform and sending data. So things like here, we're using a Google Maps device on this. This is a bit more involved to put together, just to link all the various events and triggers on the platform. And then I think the final thing is just to give an example of some of the things you can do with the Thing model, right? So I mentioned earlier that you don't need a lot of coding experience to be able to work with these, and some of the irony of me standing up in front of you today is that, you know, for most of my career I've been a hardware guy, specifically an IC developer, and doing a range of analog and digital kind of design. And so, you know, so software is relatively new for me in my career and extensive use of it. But I think what I found really powerful about the system here is that with some very rudimentary JavaScript skills, there's actually a lot of stuff you can do, and essentially, you know, algorithms and analytics you can run here. So one of the examples that I have that kind of works this through is using the accelerometer theme. You know, that when you're doing navigation systems, right, accelerometers and gyroscopes are quite common, right, for building navigation systems, especially basically dead reckoning type systems, often as a backup for GPS, right, or other sensing technologies. But pretty much every car has a backup for GPS, so it can keep track of you when you go in the tunnel, right? You know, that smart ag is a big focus for us in GPS. I mean, John Deere is a big customer of ours, and in their automated farm equipment, our systems get used in this. So, you know, there are lots of attributes that, you know, get or derivative terms that get built off basic accelerometer and gyroscope information. Some of these for navigation include pitch, roll, and yaw angles, right, as well as, so basically a vector of where the, you know, your particular device is going, right, is important. So the exercise I've kind of included here kind of shows you how to calculate that value off the raw data, right? It's kind of do some simple math and then just kind of displays those. Yes? Oh yes, IoT World Guest. Yep. Okay. Okay. So I think for the rest of this, I'm just going to move over to the actual platform itself, and just to kind of show you what's here. Okay. So I'm just going to close off here. I'm just going to log back in. Just times out after a period of time. Okay, great. So I know there were some reports of some network slowdowns earlier. This was all working great this morning. So I do apologize if, due to sort of, you know, network congestion stuff, it's kind of a risk you take at these events. We were assured that, you know, we'd have pretty good network performance here, and I think It's hard to do that when you've got a couple of thousand people kind of show up for a few days, but we did not have an opportunity to set up a specific hotspot, right, kind of our own network here, but I think for future we may do that. So I think, what I want to show you here is just the user interface, right? So there's various kind of aspects of the platform itself, where we've got a modeling section that allows us to create things, and we can thing is a very used word in IoT, right? Sometimes abused, probably abused as to what it means. Our conversations talking about things, and that get kind of comical. When in one conversation we can have a thing referring to about 4 or 5 different things, right? So it gets challenging. But basically, one of the ways to think about this is that a thing on the platform is a virtual twin for a device in the real world. There's a one-to-one mapping, right? And so we use that kind of as to represent all of the pieces, whether it's the data or the functions or algorithms that can run on that data associated with an individual device. We have a variety of different visualization tools. We're going to look at a mashup in a moment. And then, there's ways you can manage data storage, deal with collaboration, you put in wikis and blogs, and then, a variety of different tools for managing security. We don't have time to go through a lot of this today, but, the sort of the workflow you would typically build when you're, building a system, right, is you're probably going to start with a thing. Right, so I'm going to kind of go through here for a moment. This particular thing here, it's a bit. I love my long names with underscores. It's the ADI CUP 360 ADXL 362 thing, which actually corresponds to this device that's sitting right here. Okay, and if we look at what's on this, right, somebody else already has it opened up. Okay, I should warn you that this platform is not multi-tenanted, so you're going to probably see that a lot. But if I just look at it, I'm not going to edit it. You know what? I will edit it. It's my thing. Please feel free, actually, before I go any further, if you actually do want to play around with some stuff, feel free to click back on the Things modeling page. Click the little box here to the left and just hit Duplicate and just kind of make your own copy. That's a perfectly acceptable thing to do here. There we go, and you can just kind of So I just created the new thing here. I'm seeing the same. I just then go save it. Right. And so just feel free to go do that. And if we just look at the properties here on this for a moment. So, the page basically has a few things associated with just mostly documentation. Oh, sweet. Is that better? Oh, there we go. Thank you. So some of the fields here associated with the actual entity information itself are the properties. So with this thing, and there's a bit of a hierarchy here, which allows you to manage some of the complexity. So you may remember a moment ago, I mentioned that there's 3 boards here. Right? So on this, I've got the accelerometer shield, I've got the Wi-Fi device, and I've got the actual processor board itself. So one of the things you can create is this kind of hierarchy of properties and services, right, that are associated with the thing. You use a think shape for this. And in this case, I've got one for my actual accelerometer, I've got one for the board itself, and then the Wi-Fi. So the Wi-Fi device has some things like, the firmware revision. We've got some information around, the clock it's running at, and things like that. That is just, and also the device ID. Nothing, mostly static. I think we've tried some experiments with just measuring the radio power and things like that. I think I can't remember why we took it out of this version, but measuring things like that give you the opportunity to be able to kind of get a sense of what the environment is like, your radio environment is like. So there's sort of inferences you can make from that in terms of the quality of your signaling and so on. I'm going to skip over to the properties associated with the accelerometer. It's very simple. You've got an X, Y, and Z axes for the accelerometer. You can see that there's a little refresh button here I can hit that just kind of will just update this. I'm just going to turn the board over on its side for a minute, and I noticed that the update rate is relatively slow. So, but I should be able to see the values change on this, and they just did. Apologies for the eye test, but the X value went positive because I just flipped the board over on its side, and then the data got updated here, right? So, I think when you're making a new thing, and I'm just going to do this very quickly here, right? I'll just name it after myself. Okay. can't type. I'm having stage fright. So the first thing I want to do is just pick a template, right? For this, and the standard one to use is we'll just use a generic template here. And basically, what this does, I don't want to embed a video code. Sorry about that. I'll just save this real quick. And what this allows me to do here is, I mentioned earlier that with the thing model, it's object-oriented, right? So what you have is a set of associated operations you can perform on it, right? And by selecting a generic thing as a template, you pick up a whole ton of default operations, services, right, that are used to interact with the thing. Okay, I'm going to show a couple of those in a moment. But adding properties for this is very straightforward. I just go back and edit again. Right, I can just click and add a property. And I'm just going to do one, right? I've just put a name in here. I'll just do xtest, and I'll get rid of the underscore. And then I have a variety of different base types, including all of the types that are supported on the platform, as well as the things like numbers, text, HTML, JSON, and so on. So if I pick a number here, and then I'll choose to make it persistent, which means that rather than the data just being stored in memory, right, which you will lose if the machine ever goes down or you reboot it, for example. It just keeps a copy of the latest value on disk, so you always return back to that. That's kind of useful for things like, say, GPS coordinates or static information that isn't changing too often or isn't updated too often. And then logging allows you to sort of send data to a historical database. Right, so you can get into SQL type searches on this platform, but there are tools available that sort of hide some of that complexity as well, which is really useful. So I'm just going to do one here, right? And I mentioned services. So I haven't created any services yet, and that thing tutorial, number 3, kind of shows you how to do that. But these are the inherited services, right? So there's a ton of them, and a lot of them allow you to enable and disable things. You can manage access permissions. You can actually query the device. You can do searches on the history of the device, and you can write your own services as well. So a rich library of capabilities that are here out of the box. And so with just not too much our time left, actually.
Everything that you create or instantiate inherits
Yeah.
all of those.
Yeah, it inherits all of those, and then you can kind of create your own as well. And an example of maybe let me just go to the. Sorry, I'm going to look at my screen for this. I think that if I look at my Excel one for a moment, I think we've just got one service in here. And all this is doing is really just kind of updating the properties. So there's some simple JavaScript code in here, right? The one thing about the editor you get is the ability to pick snippets of code. Oh, I can't show it here. So I don't have to, if I just go to the template for this thing real quick. Right. That I can just click here. It's not. Sorry, I don't have it edited. So, but basically, you can actually there's a code snippet editor. Sorry, excuse me, but let me just show it real quick. I'm going to add a service to an existing device, and I can just show you what I mean by this. And I'll just add a service. And what I get in here, I won't do anything with this, is a ton of useful code snippets for interacting with the platform, with the device. And so, if you're not a JavaScript expert, right, by any means, and have modest coding skills, I didn't use JavaScript before I started playing with this platform. There's some simple code snippets you can just grab and just kind of pull over here. So, an info table is a representation of a multi-dimensional array. So if I want to kind of add a row to one, there's a little code snippet I just kind of popped in here that allows me to do that. If I want to create a query, right, in my service, I can just do that here. I have to look for a data shape, which just defines the array. So I'm just going to pick one and just insert the code snippet here. I'm not going to save this. This is the one time it hangs on me. All right, I may try it again. One more go. Okay, I'm not sure why it's hanging for me here at the moment. Let me try a different one. Okay, so this code probably doesn't mean a whole lot here, but I mean you can basically insert the variables are highlighted, and it actually makes it pretty easy. This plus some of the documentation makes it really easy to come up to speed pretty quickly and build some services. if I have time in a moment, I want to show a mashup real quick before we run out of time. I'll come back and show you the example I did for the inertial angle measurement in a moment. So let me kind of run to a mashup real quick, and how I want to build one. So this is the accelerometer one, which we were just looking at a moment ago, right? So it kind of shows the this one comes up here, and this is part of the challenge we're having around the network performance. It just kind of shows it here. We got a couple of sensors actually hooked in here. Some folks looks like already created some here in the room today, which is awesome. This shows a waveform from the board up here. This is where I flipped the board over on its side a few minutes ago, right? Just you see this transition here, and creating one of these is actually, this is the workspace for this. Given that we have an 11:30 stop, I'm probably not going to have a lot of time to go through this. But what we can do in here is actually, let me just quickly make something very quick, right? So in order to create a mashup, I go to the visualization section. I just click New, and I'm going to pick a static one here, so just to keep things easy. I'm presented with this workspace, and then basically what I can do is I can go and I can kind of download or use various widgets to do this. I'm going to see if I can get as far as replicating that time series chart here, and I simply just kind of drag and drop these in here. I'm also going to pick a refresh, which is going to allow me to control the refresh, right? Let me just save this real quick. And I think the first exercise kind of works you through this in kind of in pretty good detail. Shows you how to do this. So I've now set up my little dashboard. It's not very exciting, but and then I go over here and then I can pick the data I want to use, right? So you can pull data from a variety of different sources. I'm going to pick a thing, and I'm going to pick my ADXL thing. And then these are all the services I talked about earlier. So the way you actually grab data, there are two services we're going to use: the get property values. Right, one, which is going to retrieve the last data that the platform received, and then I'm going to query property history. So you can see by just typing in the whoops, QU. I can't believe this. I couldn't spell query for a moment. The query property history service here, and by just searching, I can pick up the ones I want. So the two services I want to use are the get property values, which returns the last value. And then a history, which is basically allows me to do a database search. And the platform works by triggering these services, right? So there's different events. This is all event-driven. In this case, one of the events I'm going to select is when the mashup is loaded. When you start it up first, we want to actually show the data, right? And then in order to, so if I click this property values down here, you can see on the bottom here that it's now triggered at startup, right? I'm going to use the refresh widget to actually trigger it periodically by simply dragging and dropping the connection, right? So I click on this, I grab the refresh event, and I drop it on top of the services. And now you can see, for example, with the query property history, it gets triggered when the mashup is loaded and also when you refresh, okay? The one thing what I'm going to do here is just sort of demonstrate just the gauge here, I think, in this. So if we kind of look at, so in order to do that, right, I just go to the get property values, which is going to return the last value, right, that was recorded. I'm going to select the X value, and I simply just drag and drop it over here and bind it to the data on the gauge, right? Okay, I'm going to be adventurous. Let's grab the query property history, which is grabbing my record of data, and I'm going to drop that on the chart and again bind it to the data. Right, so the first thing I just have to very quickly do here is I'm just going to configure my chart. I'm going to specify the timestamp as the x-axis, and then I'm just going to pick just one value I'm going to display. So at this point, if I save this, the only other thing I'm going to do here is I'm just going to make it pretty by adding that banner we saw earlier, right? I'm just going to, and you can customize this, for any look and feel you want. And then, we basically, when this kind of pops up here in a moment, a little bit of lag just due to the networking stuff. You'll actually see that that we've actually completed the UI design here just in a matter of minutes. So this is very simple, right? This is the transition we had a moment ago. I'm just going to poke this kind of the opposite direction, right? And I may have the refresh set to every 30 seconds. I'm just going to go back and adjust that. So if I select the refresh, the default is 30 seconds. I'm going to set it to 5. Right. And then I'll just go here and reload it. Right. This will just give us a more frequent, and you can see the transition here where I just flipped the device over, right, just a moment ago. So the gauge here, you'll notice, is out of range because it defaults to basically a range of 0 to 100. So I can set this to, basically plus or minus 2,000. And I picked plus or minus 2,000 because the sensor is calibrated in milli-Gs. So when I move, a 1G field is 1,000 milli-Gs. So if I again just reload this again, you'll see just the values update on this, right? So the X is currently now kind of registering a 0 off this. So so it's very simple to start building these UIs out, right? It kind of looks at it. I didn't really time this necessarily the best. I wasn't quite sure how this session was going to go, but you folks are welcome to just play with this while you're here during the conference. And if you're interested in learning more about it, I'll be on the. We do have a specific demo station downstairs showing this, and my colleague Manali is down there. I'm sure he'd be happy to tell you about it, show it to you some more. And also, I'll be in the ADI booth or around the floor most of the rest of today and tomorrow as well. Just kind of as I kind of wrap up here with the recovered PowerPoint. Some additional links I just want to highlight here. Just some references to the various kits I'm using here. For whether it's the 360 boards and all the sensor shields, the newer 3029 ultra low power board, and then the Wi-Fi shield we're using from our partner Inventec. And then, there's other things as well. I've included a second Dropbox link here as well, which, actually has much more detail. That's the one with the source code for all these sensor projects, right? We have about 5 of them, I think, up there, and we periodically add more. As well as, it shows you actually how to use HTTP REST interface for the platform. So the wonderful thing about this platform is that it's all REST enabled, right? So it's very easy to interact with it. You can manage your things from your edge device via REST calls, right? And we tend to do that. So for example, when we power up one of these devices first and it connects to the platform, if a thing doesn't exist, it actually goes and creates it for itself. Right. Now, there are security implications around that you have to be kind of careful about. But basically, some of the newer tools we're developing on top of this platform are to help us manage the security aspects of that. So not everybody can just get a device, connected to the platform. The last thing, just in terms of some other information, I have my business card up here. I realized what I'll do, actually, my email address is not on this presentation, so I'll just at the end briefly add it and upload it to the Dropbox again. But my business card is here if you would like to follow up with me on anything. Just to highlight where our booth is on the floor. You can reach out to connect.analog.com if you'd like more information. And if you're interested in getting involved in sort of test driving this yourselves, I mean, later in the summer, we will be rolling out a beta. We're kind of looking for people to kind of kick the tires and kind of give us feedback. I'd love to hear from you. And then I've included a short SurveyMonkey code survey. There's actually a second QR code on the pages around there. If you wouldn't mind taking a couple of minutes just to maybe give me some feedback. There's like 3 or 4 questions and no essays required. So, I'm sure we all get bombarded with surveys, so I try to keep it as simple just to kind of maybe give us, take the temperature or test the temperature here in the room today. Another QR code for that, if you want to just see if you can point your cell phone out right now and grab it. And that's it. A final thing. One of the Caroline asked me to remind folks about is that there is a draw, for a $500 gift card, and I'll just announce the winner here in a moment. But are there any questions or comments maybe before I do that and we kind of wrap? Yes, sir.
Yeah, those services that you show in the
yeah.
script, those are on the server side, right? I mean,
yes.
Things, those are, I guess you abstract all the lower layers.
Yeah, exactly. Yeah, they are running on the server. Yes. Yeah. Now, I think part of the area we're looking at is and exploring is how do we take that ease of use development environment to the edge, right? So one of the advantages we have of having our devices connected like this, right? That the ability to provide code development capabilities on the cloud, right, and then be able to via over-the-air updates, manage getting the code you develop on the cloud to your devices. So there are a couple of things we're kind of we have some proof of concepts running in that area right now, including there's a lot of development tool suppliers, especially embedded development tool suppliers, are looking to see about how they leverage cloud today and provide web-based development platforms. ARM are a very good example of that, what they've done with Embed, right? And so, certainly, the idea of having your development environment in the cloud, right, and then being able to sort of create an over-the-air update that you can then get pushed to a device is one of those areas that we have a little proof of concept project going on right now with that. And I think hopefully later with the next version of the board, the 3029, that has the connectivity built in, we'll be able to deploy that at some point in the next few months. Yeah.
You don't need to push the JavaScript all the way.
No, in that case, JavaScript is a fairly heavy language, which is interesting. It's interesting if there's anyone here in the room that are looking at device clouds or, and the edge agents that go with those, right? Hopefully, one of the things I've illustrated here today is that there's a whole world of folks out there that have edge devices that don't run Linux. So one of the things we're looking for some help with, right, is that an edge agent that is a very, very low footprint, that has a lot of the features like over-the-air updates. We're doing some work on development ourselves on that, but certainly, we'd love to talk to some folks that kind of have solved that problem. And so that's an area we're interested in. So.
Don't talk only to the hardware guys.
Yeah. So to the point on JavaScript, it's not really edge friendly, right, unless you're on a gateway level, right? There's some interesting experiments going on in MicroPython. I don't know if anyone's seen that I think we've been playing a little bit. Not sure how low power that is yet, right? But unfortunately, in a lot of cases, you're down to embedded C, which is not the friendliest place to work with, and we're trying to figure out ways to kind of abstract some of that complexity as well for folks. Love to have conversations about that as well, share some thoughts and ideas as well. Yes, sir.
Yeah, so the ThingWorks platform itself, so I imagine that's not free to use.
Right.
What
Yeah.
are the economics around that kind of
So I think the pricing and economics for that we're still kind of trying to figure out what we would charge for that, right? I think I think that.
So you may resell it.
Yes, we actually have that. We have that agreement with PTC today, right? And so, and I think that, we're not interested, like as I mentioned earlier in my comments, in being another cloud supplier, right? I mean, other folks do that very well today. Our interest is sort of enabling our customers to be able to build applications using these tools, right? And I listed a few different sort of, vendors and partners we work with, but that's not a closed list. I mean, I know there's different conversations we're having here today with, or over this period with different ways we can engage with partners to kind of, basically enhance each other's products. Yeah, so.